Good evening, everyone. Welcome to another engaging section of D-Talk 3.0. Today, we explore a critical and technology-driven topic: firefighting robots in nuclear disaster. A case study focusing on Fukushima Daiichi nuclear power plant. Our speaker, Souparnika, will guide us through how firefighting robots are used in nuclear disaster situations where human interventions become extremely dangerous. The discussion will examine their real-time applications during the Fukushima Daiichi nuclear power plant disaster, the operational challenge faced in high radiation environments, technological limitations, and their lessons learned from on-ground realities in nuclear emergency response.
Nuclear disasters create extremely hazardous environment, high radiation, intense heat, hydrogen explosions, and structural collapse. That make intervention very risky. In such conditions, firefighting robots play an important role. They help to extinguish fires, monitor radiation, inspect damaged structure, prevent further explosions, and support emergency teams without exposing to human lethal radiation. So Fukushima disaster in 2011 became a turning point in disaster response robotics globally. Next is background of the disaster. On 11 March 2011, a massive earthquake followed by tsunami struck Japan. So the tsunami damaged Fukushima nuclear plant's power supply and cooling system. So this led to reactor meltdowns, hydrogen explosions, radioactive leakage. Radiation levels were extremely high. So human workers could not safely enter into that power plant and that building. So this created an urgent need for robotic interventions. So why robots were needed? Robots were required because radiation levels were unsafe for human exposure. So there was a structural instability inside the plant and continuous monitoring were also needed. Robots could enter these dangerous zones and also they could collect data and operate without risking human lives. Next is challenge faced initially. So at the time of disaster, Japan was not fully prepared for this situation. So high radiation damaged this electronic system, communication signals failed. Inside the concrete reactor buildings, this exposed a major gap in nuclear and emergency preparedness. Next is Packboard. So one of the first robot deployed was Packboard. It was originally developed by USA for military bomb disposal. So at Fukushima, it entered into the building, measured radiation levels and captured images and also videos. It helped assess structural damage while keeping humans safe. So, however, it had many limitations such as battery level, short battery life, and also it is also vulnerable to radiation. So next is Queens. So another important robot was Queens. It was developed by Japanese researcher itself. It had tapped wheels that allowed it to climb stairs along with radiation. Sensors and thermal cameras also within that. It successfully entered highly contaminated Twins become one of the most effective robot in that disaster response. Next is Toshiba robotic system. Toshiba developed specialized radiation resist robots for inspection and debris removal. These robots conduct underwater inspections inside damaged reactors and examine containment vessels. They also specify design to survive high radiation environments. Next is firefighting operations. So these robots supported firefighting by they used to spray water and cool the overheat reactors. They detected hotspots and monitored hydrogen accumulation to prevent explosions. Remote controlled fire trucks and water cans were also used along with this robotic system. Next is major challenges. So now we see all useful and its advantages. Next is challenges. Robot face many challenges including radiation and that leads to the damage to circuits and the sensors. Thick concrete walls blocked communication signals, debris limited movement and battery life restricted operational time. So these limitations highlight the need for better disaster ready robotic technology. Next is lessons learned. So the Fukushima disaster taught several important lessons like country must maintain ready to use nuclear emergency robots. So robot must be radiation hardened. Strong communication system is also essential. Domestic manufacturing reduces delay during emergency. So robots should be an integral part of nuclear safety planning. Next is global impact. So after this nuclear disaster, Japan invested heavily on these robotic research. So nuclear plants worldwide upgraded uh, for emergency preparedness plans. Artificial intelligence and autonomous navigations are now being integrated into modern nuclear inspection robots. This disaster challenged global approaches to nuclear safety. So in conclusion, Fukushima disaster proved that firefighting robots are not optional but it is very essential for all type of emergencies. They reduce human radiation exposure, provide critical lifetime data and also supported cooling and containment operations. So therefore this event marked a major turning point in disaster risk reduction and technological invention in nuclear safety. Thank you.
If anyone has any doubt regarding this topic, please feel free to ask right now. We welcome your queries on the deployment of firefighting robots in nuclear disasters, their effectiveness in radiation zones, communication and technical barriers, ethical considerations and their future role in high-risk emergency response.
Do you think this Fukushima incident had any impact on future nuclear disaster planning?
Yes, this was the first nuclear disaster where robotics were introduced. So that influenced countries like US and even Japan also invested more for new inventories, new researches and all. So this created an impact.
Thank you. So, you know about the Chernobyl, right? So, at the Chernobyl time, they have used the mechanical those instruments to things, where the single
Chernobyl video being that we did some in the did, movie day. We saw some certain helicopters were trying to fly over that and it was getting collapsed. So how can these machines sustain in such high energy radiation?
So, the system must contain, the machine must be radiation resistant. So, with the control of human and beings, it can work effectively.
So, ideal case, how can we make something radiation resistant? Like if such a material is available, we can cover the radioactive zones. Like in the nuclear power plant, we can just cover it in that type of ideal example. Or ideal body, that substance. So, what kind of substance it is? Is there anything like that can prevent radiation?
I don't have an idea, sir. Explain.
So, how can this visualize work?
Actually, I explained that these machines contain some water cooling in it, so that will definitely help to do better.
I'm not getting proper idea. Like helicopters or even in our car, we have liquid coolants, which works better than water. In helicopters, all such machineries having such coolants. Even this coolant can get anodized type of in the presence of such high energy radiation.
These helicopter could not enter into a room, but these robots can enter. So I think this.
Suppose the radiation is, say, for example, if it is at high temperature region, instead of radiation, you imagine situation that it is high temperature. Any substance that approaches to this high temperature can burn or it can get spoiled, it can get melted, overlight, so any damage can occur on high temperature. Similarly, high energy radiation can also produce certain results I hope. So how is, what kind of equipment can persist in that high energy radiation?
I don't know, sir.
Thank you, Souparnika, for this insightful presentation on firefighting robots in nuclear disasters, a case study focusing on Fukushima Daiichi nuclear power plant. The section offered a balanced and practical understanding of how robotic technologies supports nuclear disaster management while also addressing the operational and technological challenges faced during the Fukushima incident. With DTOC 3.0, we continue to engage with important topics that enhance our understanding of technology, resilience, and disaster preparedness. Wishing everyone a pleasant evening, and we look forward to seeing you in the next sections.